So when I talk about organic compounds in a family, there are 4 aspects that I want you to know it by heart. And that's how I teach, because I like to be organized about it. 1 is how to name this compound. 2, how to prepare this compounds. 3, what are the physical properties for this class or for this family of organic compounds? And 4, what are the chemical reactions? For alcohols, because preparing alcohols, there are a lot of reactions. And then the reactions of alcohols, because it's a long chapter, it was divided in 2 chapters. Chapter 10 is part of Organic 1 class, which is, it basically covers naming of alcohols, physical property, and preparation of the alcohols. So I want to make sure that you know how to name alcohols and know general information, general idea about physical property. Can you tell me what is responsible for physical property of any organic molecule? And a sample example for physical property would be melting point, boiling point. You can use the chat option to answer, or you can use your mic. Tell me what's responsible for physical property of a compound, basically like a cause and effect type. What will give a organic compound high boiling point versus low boiling point? And I'm sorry, I don't want to, repeat something, but once in a while I check when I'm recording. I want to make sure that you can hear my voice. Okay, can you hear my voice? That's great. Okay. Its composition, bonds, okay. Anything else? Presence of hydrogen bond, that's good. Presence of, what is like general term for the hydrogen bonding? Intermolecular forces, very good. Intermolecular forces are responsible for physical property of the compound, organic molecules specifically. So if you have hydrogen bonding, because it's the strongest intermolecular force for molecular compound, then the compound is going to have higher boiling point, higher melting point, higher viscosity, higher osmotic pressure. The only thing that is low is the rate of evaporation, or the vapor pressure is low. At the same time, you can determine solubility of the compound in solvents. If you have organic compound that has hydrogen bonding, most likely it's going to dissolve in water. But if the organic compound has a long carbon tail, which is the cutoff is like 5 carbon, if you have 5 carbon or higher than 5 carbon, is not going to dissolve in water, but still it would dissolve in other polar organic solvent. So solubility can be predicted based on intermolecular forces as well. So you can predict solubility, you can predict melting point, boiling point, all physical property of the compound. How do we know what type of intermolecular forces you have for the molecule? If your molecule contains like OH, NH, or FH, then your compound is going to have or behave hydrogen bonding, and hydrogen must be directly attached to oxygen, nitrogen, or fluorine. So based on the structural formula for the compound, you can predict the type of intermolecular forces. If your compound contains like polar bond, that means your compound is polar, or uneven distribution of the electron throughout the molecule, that makes the molecule polar. Then you have like dipole-dipole interaction for the compound. Polar compounds, they have higher boiling point or stronger intermolecular forces, which is dipole-dipole interaction, compared to compounds that they have no dipole moment, or if they are not polar, like alkanes, like aromatic compounds. If they are not polar, they are going to have weaker intermolecular forces, which is like van der Waals forces or London dispersion forces. And as the molar mass increases, London dispersion is going to increase. London dispersion increases forces, they exist among all sorts of molecules, regardless of the uh, bonding, regardless of the polarity. If it's water molecule, you have London dispersion plus you have the hydrogen bonding. If you have just alkane, you have pentane, it's only London dispersion because it's nonpolar compound. London dispersion increases as the molar mass is going to increase. So anyway, so we talk about physical property, not just alcohols. Any compounds, any class of the compounds that we start with, we talk about physical property. Are they expected to be soluble in water or not? Then we talk about how to prepare these compounds. You learn preparation of alcohols, like hydration of alkene, reduction of ketone that gives secondary alcohol, reduction of aldehyde that gives primary alcohol, reduction of carboxylic acid and carboxylic acid derivative using LAH or aluminum hydride. Then you have the LAH, lithium aluminum hydride, sorry, with the LAH, which is going to be a strong reducing agent, and that would reduce carboxylic acid. These are review from chapter 10. I do have a PowerPoint or folder review for chapter 10, and I want you to review it for better understanding of chapter 11. So if you look at the reactions, you said that some of the reactions of alcohols was already covered, and you were in the Grignard reagent. So Grignard reagent is usually used for preparation of the alcohol. So I'm kind of wondering if Professor Larry actually finished chapter 10 or still was working on chapter 10, because Grignard is use of the Grignard reagent to prepare alcohols. Can anyone help me with that? Was it still chapter 10? Still working on chapter 10. Okay. So still working on chapter 10. So should I go back to chapter 10, start on chapter 10, or start chapter 11 already? Because that's preparation. That would have been the last part of the chapter 10. I can't, okay, the time, especially for summer, is not going to allow us to be very slow. I can go for the chapter 10 to have a review of chapter 10, or I could do a video recording of lecture for chapter 10 and post it for you so you can watch that. I want to, since I gave you the option, I don't want to say no, I asked your opinion and I'm not going to do it, but at the same time is not going to be enough time for us to cover chapter 11 through 22 if you spend too much time on 10. So I'm just going to go and talk about some of the reactions for some of the recording. Okay, that's deal. I will do the recording of the chapter 10, and I will post the recording as a YouTube video for you in the course, so you can watch and you could bring your questions to me. Definitely, no problem. Okay. So I just looked at this, like the outline of the chapter, and I said, well, these are not, Grignard is not here. That's why I kind of paused. Okay, for chapter 11, which is more of the reactions of alcohols. So you already know hydration of alkene that would give you alcohol, right? Dehydration of the alcohol would change to alkene. This is just the overview, is not the reaction. I will go over the each of these reactions. So these are the type of reactions. One is dehydration of alcohols. Then you have oxidation to aldehydes and ketone. If you oxidize primary alcohol, you would get aldehyde. Secondary would give you ketone. Substitution to form alkyl halide. reduction to alkane, and I will cover each of these reactions. So let's move to the next slide. And I just learned about this. Okay, very good. So a summary reactions, and I will go over each of these reactions again with the example of them. And if you have any questions at any time, please ask me. You can use your mic, or you could use the chat. So I'm just going to move the chat box to the other side. Okay, again, general reactions in dehydration, alcohol would change to alkene. This is a good place for you to, as a review or like quick review. Then we talk about the, detail of the reactions and then the following slides. Oxidation of the alcohol, of course, you need oxidizing agent. That would change to ketone, aldehyde, or carboxylic acid. You can do substitution reaction. You can do reduction reaction. Just as a review, in general chemistry, when you were talking about different type of reaction, can you name few reactions in the general reactions in general chemistry? You can use the chat box, or you can use your mic. Acid-base reaction, which is neutralization reaction. What else? Oxidation reduction reaction. Very good. You had combination reaction, right? Combination reaction. You had decomposition reaction. You had single displacement reaction. You had double displacement reaction, and neutralization reaction with oxidation reduction. So those were like 6 major, and then combustion. Combustion is everywhere. For organic compound is also a major reaction. So when you are talking about reaction, think about general type of reaction and say, does alcohol go through that type of reaction? And if it does go, what is the reagent for that reaction? And what is the product for that reaction? Organic chemistry too has a lot of chemical reactions. So you'll be lucky if you learn about only reaction and the reagent and products. So learn how to approach the problems like the reactions. Make sure you know what the reactant is, what is the reagent, and what would be the product. So this reaction, kind of the first reaction, if we categorize it, it looks like a decomposition reaction because you're removing water and changes to alkene. You have oxidation reaction. You have substitution, just like single displacement reaction. You remove OH and you add X. You do reduction reaction, again, just like oxidation in reduction. What is reduction in organic chemistry? What would you think about when you say reduction? What's the definition for reduction in organic chemistry? Like in general chemistry, I tell you what it is. Lose of electron, Leo, is oxidation. Lose electron is oxidation. Gain of electron is reduction. What about in organic chemistry? What is oxidation? Oxidation means lose of 2 hydrogen. So if it's 2 hydrogen removed from minus the 2 hydrogen, this is oxidation, okay? Oxidation, lose of hydrogen, plus 1 oxygen, that's oxidation. So what is reduction? For reduction is going to be gain of 2 hydrogen, that's reduction, or minus oxygen. If you remove oxygen, is going to be also reduction. So reduction meaning adding hydrogen or removing oxygen. Oxidation is opposite. So you learn one, you expand the knowledge to the other one. Esterification is another like substitution reaction or a condensation type reaction. Is a kind of combination reaction rather than the substitution reaction, because it's combining carboxylic acid with alcohol that gives you ester. Tosylation is a substitution reaction, and then formation of an ether is like 2-step reaction. We will talk about each one in detail. And in order, so I want you to first make sure that you know the name of the reaction. Second, know and memorize list of all oxidizing agents. Believe me, it's going to help you a lot. I've taught organic chemistry to lecture for last 10 years, at least every semester at different schools, like summers at Broward College and fall and spring at NOVA, Southeastern University. So I always, students who make actually lists and they just build up on that list, they are happier at the end of semester because they already know all the reagents. So some inorganic like reagents that you already know, oxidizing agent, chromic acid is oxidizing agent, and you have permanganate is oxidizing agent. Definition for oxidation, as I said already, gain of oxygen, like one oxygen or two oxygen, this is just oxidation. Gain of halogen, if it gains two halogens, like is going to be oxidation. So gain of X2 is going to be oxidation. Lose of H2 is oxidation. And reduction is kind of opposite to oxidation, because when oxidation happens, one is oxidized, another one is being reduced. So gain of hydrogen is reduction. Gain of hydride ion, please remember you have hydrogen atom. Okay, you have hydrogen with one electron showing, that's like a free radical. You have H2, that's hydrogen gas, that's how it appears in nature. You have H minus, this is the hydride ion, and you have a H plus, you have hydronium ion. Make sure you know the difference between all of these. So if H2 is added, meaning that two hydrogen is added to a organic molecule, let's say you have a carbon-carbon double bond, and then you add H2. And remember, hydrogenation requires a catalyst. And since you know this already, I'm not going to talk about it because you learned that in chapter 8. Hydrogenation requires a catalyst like nickel, platinum, or palladium. It does require a heterogeneous metal or catalyst. The product is going to be addition of hydrogen to one hydrogen to each of the carbon carrying carbon-carbon double bond. The product is going to be alkane. This reaction is classified as reduction because you're adding two hydrogen. If you add H minus, which is the hydride ion, that is also considered a reduction. H minus, what's the nature of H minus? I'm just throwing these terms because we need all these terms to learn organic reaction. What is H minus? I mean, these are your choices. Is it electrophile? Is it nucleophile? What type of a species is that? Is it free radical? Is it a carbocation? What is it? Is it electrophile or nucleophile? Because the other two are just basically busy answers. So is H minus electrophile or nucleophile? H minus? I'm sure you can hear me, right? Please say yes if you can hear me. Just want to make sure you hear me. Okay. So electrophile, perfect. Electrophile, what does it mean? It means that it likes electrons. What type of species would like electrons? Something with positive charge or something with negative charge? Please respond. So perfect. That is something with the positive charge is considered to be electrophile. So if H plus is like classified as electrophile, it likes electrons, is looking for high density of electron, is going to attack a part of the molecule that has high density of electron. When it comes to H minus is the nucleophile. What do you find in the nucleus of the atom? Which subatomic particles are in the nucleus of the atom? You need some general chemistry. You need to remember some of the general chemistry still. What do you find in the nucleus? Protons and neutrons. You find a positive charge in the nucleus. So when you say nucleophile, that means something that likes positive charge. So what should be the charge on that nucleophile? It should be either negative charge or it must have pair of unshared electrons. So when you say nucleophile, it's something that is looking or likes nucleus or likes positive charge. So H minus is a nucleophile. So when you are reducing like aldehyde or ketone, you bring hydride ion, and I covered that reaction. So this is like general terms that you need to know: definition for oxidation, definition for reduction, and then learn about and know some of the reducing agents and oxidizing agents. So can you name other oxidizing agents that you learned already? Can you name a couple more oxidizing agents? Any oxidizing agent from organic or inorganic chemistry? H2O2 is oxidizing agent. This is not oxidation, this is oxidizing agent. Okay, H2O2. We already know about permanganate, KMNO4. We know about permanganate in H plus or OH minus and heat. Okay, when you have this is known as a strong agent, a strong oxidizing agent. But if you have dilute and cold permanganate, so if I say cold permanganate, this is going to be weak oxidizing agent. Weak oxidizing agent, ox agent. So you have a strong oxidizing agent, you have weak oxidizing agent. So it depends on what you want to do. You want to oxidize one step or you want to oxidize two steps, then you have to choose. So you have to know the oxidizing agent first. So when you are thinking about the reaction, to pick the proper one. Now, what about the reducing agent? Can you give me examples for reducing agent? Reducing agent. Just a couple examples for reducing agent that could provide hydrogen or it could provide H minus. Reducing agent. Proxy acid was also oxidizing agent. I didn't put them all, but I just wanted to give you some examples, okay? H2 with platinum, nickel or palladium. This is reducing agent. Sodium borohydride. This is reducing agent. This is weak reducing agent. What else? Lithium aluminum hydride. Lithium aluminum hydride, a strong reducing agent. Okay, this is a strong and that's weak. This is also strong, but it works on the unsaturated carbon or hydrocarbons. Ether. What is ether? Ether is this, CH3O, CH3. This is a dimethyl ether. You could have diethyl ether or dimethyl ether. The one that you are using in the lab for the solvent is a diethyl ether. This is also ether. Ether is actually a very good solvent. So when you are working with Grignard reagent, ether has pair of unshared electron on the oxygen, and the pairs of unshared electron on oxygen is going to help and stabilize the Grignard reagent. But it's not oxidizing, it's not reducing, it's just a very good organic solvent. So in order to learn about oxidation reaction and reduction reaction, you need to know what are the oxidizing agent, because if you don't know the agent, so how are you going to change the alcohol to carboxylic acid, or how are you going to change that to the aldehyde or ketone? Sorry, PCC is a weak oxidizing agent, weak ox agent. Okay, PCC is a Pyridinium chlorochromate is a weak oxidizing agent. And then you have like Jones reagent. This is a Jones reagent. That is oxidizing agent. Silver nitrate with nitric acid, that's oxidizing agent. But we don't use that a lot here. We use a lot of PCC for oxidation and controlled oxidation because it's a weak oxidizing agent. We use a lot of sodium borohydride when we want to reduce something, aldehyde or ketone. This is a weak reducing agent. We use lithium aluminum hydride as a strong reducing agent. We use hot permanganate as a strong oxidizing agent. Okay. So, more about oxidation. What do we know about the oxidation? Which one is more oxidized, a primary alcohol or alkane? Alcohol or alkane? Which one is more oxidized? What is the change from alkane to alcohol? How do we know that this is oxidized? What happened based on definition for oxidation? Going from alkane to alcohol, gained oxygen. Perfect. Thank you. Gained oxygen, and gaining oxygen is oxidation. So if you were going to reduce the alcohol, you have to go to the left. You have to change the alcohol to alkane. Now, if you want to oxidize alcohol, you go from alcohol to aldehyde. You can go from aldehyde to carboxylic acid. So if you go to carboxylic acid, that's even like addition of 3 bond to oxygen. So how does it change from alcohol to aldehyde? It's addition of 2nd bond to oxygen. So carbon is forming double bond with oxygen. That's like 2-step oxidation. Or what is happening? What is more visible than that? Going from alcohol to aldehyde. How do we know is oxidized? Based on definition. So here you said add oxygen. And what happens here? Another bond to oxygen. What else? Which is more visible? Remove 2 H's. See, remove hydrogen. Okay, you remove 2 hydrogens. The green hydrogen, the green color hydrogen are being removed. Just please get used to in the reduction, you remove 2 hydrogen, because if it's just 1 hydrogen, it's not going to be enough for the reduction. So just make sure that you mention about 2 hydrogens. Now, going from aldehyde to carboxylic acid, what happened? Practice definition for oxidation. Is more oxidized, but what has happened? It could be one of the same answers you had already. Gain a 2nd oxygen. So it's add oxygen. That defines that from alkane to primary alcohol, or to alcohol, to aldehyde, to carboxylic acid. Each one is like 1 step of oxidation, or additional step of oxidation. And when you go opposite, it's going to be reduction. Now, in order to go forward for oxidation, you need to know your oxidizing agent. And it's going to be very specific for your oxidizing agent. So how would you make sure that when you oxidize, but you start with alcohol, because we are in chapter 11. So how would you stop here? What would you do to make sure that alcohol oxidized but stops in aldehyde is not going to go to carboxylic acid? What do you think? How do you think you should modify the reaction mixture to stop in the aldehyde step? I give you a hint. Should I use a strong oxidizing agent or weak oxidizing agent? Weak oxidizing agent. Very good, very good. Can you also give me example of weak oxidizing agent? It's okay. You don't have to, no pressure. You did good. PCC, very good. PCC is a weak oxidizing agent. So if you want to go from primary alcohol to aldehyde, you have to use PCC. If you want to go from alcohol to carboxylic acid directly, what would you do? What type of oxidizing agent should you use? Strong or weak? So in this case, you have to use, because it's two-step oxidation, you have to use a strong oxidizing agent. With the strong oxidizing agent, examples, hot permanganate, that was a strong oxidizing agent. To give you another name, to make it familiar with another name, is sodium dichromate, NaCr2O7, okay, with H2SO4, you mix the two together, and this is the strong oxidizing agent. If you use a strong oxidizing agent of sodium dichromate with sulfuric acid, your primary alcohol would change directly to carboxylic acid. But if you use a weak one, it will stay in aldehyde position. Now, that's for primary alcohol. What about secondary alcohol? If you go from secondary alcohol to ketone, first of all, can you oxidize secondary alcohol? In order to oxidize, you have to add a oxygen or remove two hydrogens. For a secondary alcohol, you cannot add another oxygen because it's attached to two other carbons. So it can be attached to only one oxygen because it's attached. You don't have like carboxylic acid in the middle. Then it would give too many bonds. So you have the other definition. Using the other definition, can we oxidize secondary alcohol? Or what makes the secondary alcohol to be able to oxidize or to go through oxidation? You have two hydrogens there, because oxidation is from alcohol to aldehyde or ketone is removing hydrogen. If we had only one hydrogen and not this one, we could not oxidize it. Since we have these two hydrogen, we remove these two hydrogens, so remove two hydrogens, and it changes to ketone. So now we have ketone here. Can you oxidize further? If I bring like a strong oxidizing agent, can you oxidize? The answer is there, but can you tell me why you cannot oxidize? Your carbon is attached to two other carbons, so you cannot add another. Okay. All bonds are full. And there is no hydrogen to remove. And you must have like hydrogen attached to this carbon in order to oxidize it. So there is no hydrogen attached to this. There's one method that you could do. Actually, you can change this to ester when you deal with the like inserting of oxygen into ketone. You do not learn that until like chapter 22, and I don't want to overwhelm you with this. For now, we're just going to say no further oxidation for ketone, okay? No further oxidation for ketone, but aldehyde can go to carboxylic acid. Okay, what about tertiary alcohol? Can you oxidize tertiary alcohol? Or why you cannot oxidize tertiary alcohol? Simple words. In order to oxidize a secondary alcohol, you must remove the two hydrogens. But for tertiary alcohol, you don't have two hydrogens, you only have one hydrogen. So since there is no other hydrogen in this carbon, tertiary alcohols cannot be oxidized. So in the lab, we actually use this in order to identify the alcohol. So if you cannot oxidize, let's say you add chromic acid and you cannot oxidize, or it doesn't oxidize, that means your alcohol must be a tertiary alcohol. So you can actually use this to your benefit for identification of unknown compound. Okay. Secondary alcohol becomes ketone. The reagents that you are using, it could be, now, do you have to use PCC for this? Does PCC work for secondary alcohol? For secondary alcohol, PCC works, and a strong oxidizing agent also works, but it's which one is better, like a PCC or the strong one? Usually for the safety, we go with the weaker oxidizing agent. But since ketone doesn't go to carboxylic acid or doesn't go to ester with a strong oxidizing agent unless you have a specific catalyst, which we are not going to cover that in this chapter, you would say it's okay to oxidize secondary alcohol with a strong oxidizing agent. So we get to ketone. The chromic acid reagent. This is when you mix the sodium dicarbonate with the sulfuric acid, is going to give you chromic acid, and chromic acid is the oxidizing agent. In order to prepare that, you can either add chromium trioxide in aqueous solution or in acidic solution, or you add sodium dichromate and the sulfuric acid. Regardless, I mean, it's not the inorganic chemistry, so you won't be asked which one or how would you prepare the chromic acid, but you need to know that if you have sodium dichromate or chromic acid as the oxidizing agent, that is a strong oxidizing agent. If you add to primary alcohol, it would go all the way to carboxylic acid. If you add to secondary alcohol, it would go to ketone, but since there is no further oxidation for ketone, it will stop in that stage as a ketone. Okay, in this stage, so when you are studying the reaction kind of step by step, which is the mechanism for the reaction, if you look at this step of the reaction, where you actually need this hydrogen for it to drop in the electrons. So this hydrogen is removed, these electrons are dropped in order to form the ketone. The presence of this hydrogen is very important. So if you don't have a secondary alcohol, and if it's a tertiary alcohol, if this was an R here instead of the hydrogen, this step was not possible. And since this step of the reaction was not possible, then tertiary alcohols do not go through oxidation. So what makes the difference is this presence of this hydrogen. For primary alcohols, you have two of them. For secondary hydrogen alcohols, you have one hydrogen that is needed to drop in a pair of electrons to form the carbon-oxygen double bond. But for tertiary alcohols, you do not have this hydrogen. And since you don't have that hydrogen, tertiary alcohols do not oxidize. Very good, very good. About your responses, very good. So primary alcohols, this is just the Explanation, I already told you I already talked about oxidation of primary alcohol to aldehyde or carboxylic acid, two choice. This is just giving you more examples. I do have like some class problems because some students are not here. I'm going to do the class problems during our next meeting, even though this is recorded, which is good, is going to help the students, but I want you to be able to solve problems, because if you solve problems and if you actually go to end of the chapter problems and do a lot of like practice problems from end of the chapter, is going to make you learn the chapter inside out, and then you be prepared not only for your exam, not only for the final exam, you will be prepared to study for your all the CATs that you have, the MCAT or PCAT, or the course, the entrance exams that you have to take in near future. So I kind of emphasize on the reagent. Know your reagents. If you don't know reagents, you're not going to do well. One day after the exam, I asked students in class at NOVA for Organic 2 class specifically, I asked any suggestions for people for next semester they are taking this class. What do you suggest, or what is the hint? What would you tell them to do? It says, memorize your reagent. And I said, didn't I tell you? He says, yes, you did tell us memorize your reagent, but until we sat for the exam, we didn't realize how important it is for us to memorize our reagent, because it's going to make a huge difference. Let's say if you have primary alcohol and then you have the final product as carboxylic acid, the choices, even multiple choice questions, you have like PCC as one of the choices, and then the sodium dichromate. The only way you can answer those questions, and then the other choice would be like sodium borohydride. The only way you can answer those questions is if you already know that these two are both oxidizing agents. So is oxidizing agent, ox agent. This is also ox agent. So you need to know this by heart. Second thing you need to know is that PCC is a weak oxidizing agent and sodium dichromate is a strong oxidizing agent. What happens if you add sodium dichromate to primary alcohol? It would go directly to carboxylic acid. But if you add PCC or pyridinium chlorochromate, if you only know about the PCC, this is the structure for pyridinium chlorochromate, then the reaction is going to stop in the aldehyde stage because this is a weak oxidizing agent. So PCC would oxidize primary alcohol to aldehyde, secondary alcohols to ketone. Sodium dichromate would oxidize primary alcohols all the way to carboxylic acid, because sodium dichromate can oxidize aldehyde. So in here, if I add sodium dichromate here with the H2SO4, is going to change to carboxylic acid. So I'm going to have COOH here. So I'm sorry, RCOH. So it's going to, sodium dichromate can oxidize the aldehydes. Any questions? I'm going to give you like 30 seconds. Wait for your questions. Tell me you have questions. You know, you can raise your hand. You can use your mic. You can use the chat and tell me about your questions, if you have any questions so far. You know the difference between weak and strong oxidizing agent. You know that primary and secondary alcohols do oxidize, but tertiary alcohol do not go through oxidation reaction. Do you have any questions? If you don't have questions, please just say in the chat area that you know you don't have questions, so I can move on to the next. No questions? Okay, perfect. No questions. Good. Okay. This is a summary. Secondary alcohol, to oxidize secondary alcohol, you could get ketone. You can have a choice of using chromic acid or PCC. If you use primary alcohol with PCC, it would give you aldehyde. But if you have primary alcohol with chromic acid, you would get carboxylic acid. List for other reagents, and these are oxidizing agents. The copper oxide at 300 degrees Celsius is dehydrogenation. It means that it removes hydrogens. Collins reagent, chromic trioxide. And then you have your Jones reagent, chromic acid in acetone. KMnO4, your KMnO4, it's a strong oxidizing if it's involved, heat is involved. So basically I call it like hot permanganate in acidic or in basic solution. If it's a cold dilute permanganate, is going to be considered as weak oxidizing agent. You have seen this reagent before. When you add cold dilute permanganate to carbon-carbon double bond, you would get diol. When you add hot permanganate, you would get carboxylic acid. So you would see the cleavage actually. Okay, so just the most appropriate method in the lab, what would you use? Would you use sodium dichromate or you would use PCC in this case? You can use PCC. You can use sodium dichromate with the sulfuric acid. They would all give you, it would give you that. And then for the dehydrogenation, for the industry, you don't want to bring that to the lab because it's going to be just more expensive. It does work on the paper, however. Octene 1-ol, 2-octene 1-ol, and you want to change it to aldehyde. Okay. How would you change that to aldehyde? Because it's a primary alcohol. Sorry. Because it's a primary alcohol, you would use, if you want to keep it in the aldehyde, you must use PCC. And what is dichloromethane or methylene chloride? This is just a solvent. So this is not the major reagent. That's just a solvent. Okay. So because if you want to stay in aldehyde stage, we cannot use sodium dichromate. We cannot use hot permanganate. There's just a difference in the what needs to be used, what could be used. The CuO, copper 2 oxide with the heat. This is the industrial method of dehydrogenation as well. Since the hydrogen gas is being released, that's what makes a difference. In the lab, if you have hydrogen gas released, you are increasing the chance for explosion or fire. It can catch on fire very easily. So because that safety factor is involved, this reaction is known for the industrial method and not proper for the lab. For the lab, permanganate, sodium dichromate, and PCC is a better method. So for the laboratory setting, we don't use that. Oxalyl chloride. Oxalyl chloride is also a oxidizing agent, and it can change the secondary alcohol too. So when you have a choice, when you have choices, then you pick if you know your reagents, you are going to actually pick the right, okay. You're going to pick the right reagents, especially if it's a multiple choice questions. So the condition is for you, you have to know your reagent. Dimethyl sulfoxide, it's a solvent again. This solvent you probably know from SN1, SN2 type reactions or E1, E2 reaction. Dimethyl sulfoxide, it's a polar aprotic solvent. So just like acetone, this is a polar aprotic solvent that can be reduced, okay, also in the process. Other reactions of aldehyde. Any questions for me before I move on? Okay, exam questions. I'm glad that you said something. I was going to talk about it anyway next class when we have more students, hopefully, in the class. The type of questions, I hope that I have time to prepare quizzes, and I give you like quizzes. And when I give you quizzes, that means that you are going to have questions similar to the quiz questions on the exam. You are going to get assignment for each chapter, and questions to those assignments or questions in those assignments, they are going to be very similar to the questions that you would see on the exam. I would modify the syllabus between now and Wednesday, and I talk about the assignments. I'm going to count how many assignments I'm going to give you, and I would tell you how I'm going to grade it. But for you, as far as your responsibility would be to do all the assignments. You might think that is like a lot of work, but that's one of the best ways to learn the topic, to learn the chapter, and to be prepared for the exam. Okay, any other questions? Any questions? Okay, if no questions, we talked about electrophile and nucleophile already. So alcohol can act as a nucleophile, alcohol can act as electrophile. The difference is, it's showing here that if you have cleavage of oxygen-hydrogen bond, and how would you do this? How would you cleave? How would you remove the hydrogen? I'm asking you, and you're not being graded on this, but I just want you to think out of the box. You don't have to memorize everything. You can tell me general answer, and hopefully one of your general answer would be a specific answer to this question. What would you bring? What type of reagent would you add to cleave off hydrogen from the oxygen? What you're actually doing there? What would be the reagent? Nature of the reagent? You don't have to give me the name of the reagent unless you know it already. What are you trying to do? What's another way of saying that? Instead of saying cleavage between oxygen and hydrogen, what can you say? Are you removing an element from there? Are you removing part of the molecule? What are you removing? When you say cleavage between, in this molecule, when you say cleavage between oxygen and hydrogen, what are you removing? The smaller piece. You are removing hydrogen. Very good. Now, what type of reagent you would bring to remove hydrogen? What is hydrogen? Or you can correct it in the chat because it's recorded. I'm going to put, you are removing H plus, basically, right? Removing H plus. What type of reagent you would bring to remove H plus? It may not be something that you need for this slide, but if you think that way, it's going to make you stronger in like answering multiple choice questions when you're taking entrance exams. OH maybe, very good, very good. Other responses? That's a very good starting, but you can give me like general answer. Okay, if I tell you that I need a base in general, okay, so I give you a hint, or you already told me, you told me that you need a base. Okay, now if you need a base, what type of base do you need? Do you need a strong base or you need a weak base to remove hydrogen from alcohol? And how would you know that? Do you need a strong base? Very strong base. You need a very strong base to remove hydrogen from alcohol. Can anyone tell me why does it have to be very strong base? I don't like to call names in during the class, but I do expect people, everyone to participate. So I appreciate if you all can contribute. Maybe you have an answer as well. The attraction between a hydrogen and, okay, attraction between hydrogen and H is a strong bond, but you also have, like for carboxylic acid, if you have a carboxylic acid, do you need a strong base to remove that hydrogen? So in general, let me help you because you are here to learn, not to teach me. So I'm going to help you. If the compound that you have is a weak acid, this is a very weak acid, right? How do you know it's a weak acid? Hopefully you're over age 21. And if you're over age 21, you know that ethanol is an edible alcohol and you drink it. If it was a strong acid, it would have burned everything. But you can drink it, so it's a very weak acid. Because it's a very weak acid, for a very weak acid, you have to have very strong base. So because this is a very weak acid, so I'm going to write here for a record, needs very strong base to remove hydrogen. To remove that hydrogen, because it's coming from very weak acid. If you remove this hydrogen, you are removing a H plus, right? What's going to happen to these electrons? Electrons are going to go to the oxygen, and this oxygen is going to change to negatively charged ion. So we call that alkoxide. Okay? So alcohol has lost the hydrogen, has changed to alkoxide. Alkoxide is a strong base, has a negative charge, so it classifies as a nucleophile. So alcohol can change to a nucleophile. Alcohol, if you remove the OH, is going to, if the cleavage takes place here, oxygen is going to remove the electrons. So you are going to remove OH minus. And if you remove OH minus, the carbon that is left here is going to be plus charge. And if the carbon is left there is plus charge, it's called carbocation. And carbocation is electrophile or nucleophile? Carbocation is going to be, say something, write on the chat. carbocation, carbon with a positive charge. If carbon has positive charge already, carbon has positive charge is not nucleophile. If carbon has positive charge, is looking for what? Something with negative charge. So if it's looking for something with negative charge, what is that something with the negative charge? Is electron. So if the carbon is positively charged, is known as a electrophile. H plus, is it electrophile or nucleophile? It's electrophile because is positively charged, is looking for negative charge, which is found on the electrons. But in this case, when you have CO minus, already has a negative charge, is looking for positive center, is looking for nucleus, because nucleus is positive charge, nucleus of the atom is positively charged, so you have it positively charged. Okay. So is negatively charged, is looking for a nucleus, so it's classified as nucleophile. So alcohol is a weak nucleophile itself. Okay, alcohol is a very weak nucleophile. What makes the alcohol to be nucleophile? What is nucleophile? Nucleophile is looking for positive charge. So if you have alkoxide ion, definitely is going to be a strong nucleophile because it has negative charge. It's not very stable. But if you have ROH, this is also classified as a nucleophile. We learned that in SN1, SN2 reactions. Alcohol is weak nucleophile, but what makes the alcohol to be nucleophile is the pairs of unshared electron on the oxygen. When you have those pairs of unshared electron on the oxygen, it makes the alcohol very attracted to a positive charge. So it can act as a nucleophile, but at the same time, because it's stable on its own, it is a very weak nucleophile. After losing hydrogen, it becomes a strong nucleophile. Questions? If you have any questions, you can interrupt me. Okay. Just a review from SN1, SN2 reactions. What is SN1 reaction? Can you tell me what is SN1 reaction? What does the name stand for? SN1, unimolecular nucleophilic substitution. 1 stands for unimolecular, N stands for nucleophilic, and S stands for substitution. SN2 is bimolecular nucleophilic substitution. In both reactions, you want to have, proper alkyl halide, but for both of them, leaving group is going to be also a factor, like how fast the reaction is going to go. Now, what is a good leaving group? Which one is a better leaving group? Hydroxide ion, OH? Is this a good leaving group or Br minus? Which one is the better leaving group? Is OH a good leaving group? It's not, right? OH is not a good leaving group. OH is very weak leaving group. Now, if you want to change alcohol to something else, then you don't want to deal with this OH. You cannot move the hydrogen. You cannot move because it's very weak acid. You cannot move OH because OH is not a good leaving group. So one of the solutions for that is to tosylate alcohol. This reaction here is known as a tosylation, TSOH. So you're going to tosylate this reaction. And when you tosylate, you are going to just learn about the TSOH. Even if you don't remember this structure, you should be able to recognize the structure. If you don't remember to draw it, it's okay, as long as you know the TSOH, just the abbreviation for that. So you have the paratoluene sulfonic acid, which is the tosylation reagent, and then you are going to tosylate the alcohol. What happens when you tosylate the alcohol? The H from the alcohol with OH from water is going to, from the reagent is going to form water, and it leaves, and then you get a new bond here. So instead of OH, now you have OTS. So you have ROTS. This is a tosylated alcohol. So what happened? The same way that you have learned before, like to make the OH better leaving group, you change the OH to OH2 by protonation. It changes to water, it changes to better leaving group. This is another way. You can just look at it that way. So you are changing OH to OTS, which is a bulky group, is a better leaving group, and you have a good leaving group. Now this reaction can go to SN2 reaction very fast. You can bring Br, this is going to leave and replace with Br. You can bring H, this would leave and you get alkane. So you can bring any nucleophile, is going to attack this and make the OTS leave. So when you tosylate alcohol, it changes to a good leaving group. So alcohols can be converted to tosylated ester. The tosylate group is an excellent leaving group. When do you need the excellent leaving group? Is for substitution reaction, SN1 or SN2 type reaction. Okay, let me see if I can stop somewhere. What time do we have anyway? Okay, it's 7:28 and we had no breaks. I can stop it. Let me pause this first. Sorry.